Hi everyone, welcome to ST Skills. This is a weekly system design session, and we normally discuss a deep dive system design topics on one week and mock interviews on the following week. So we alternate this. So if you are looking to participate, please feel free to join the Discord and like ping one of the organizers to get started. And today we have Praveen volunteering to discuss the Netflix architecture, so which I think is an interesting one. So I'll give forum to Praveen, and before that, I just want to let you know that like you can join the discussion, or you can stop Praveen, or like us if you have any questions, or if you like to provide your inputs and to make it interactive and useful for all of us. And towards the end of the session, like we'll have some time reserved like for informal chit chat, and it won't be recorded. So yeah, with this, Praveen, please get started.
Thanks, Naga. Good morning, everyone, or good evening, wherever you are, or good afternoon. This is Praveen Sattaru. I've been in technology world for last almost 20 years. I worked in Microsoft for almost 8, 9 years, and now I'm with T-Mobile. Uh, I build large-scale system designs for almost 2 decades, and I was one of the core founders for the Bing platform with multiple patents and ads and networks. And I do lots of POCs on different infrastructure uh, setups and configurations and coding. That's enough of me. And I, when Naga reached out to me this week asking me what topic I should watch, my kids were watching Netflix, and the Netflix was buffering. And then I thought I was planning to give a deep dive into load balancing or some other interesting white papers, but I thought, let me give a view of, I don't call this system design, I don't call it system architecture. I'll give you a view of Netflix that after I watched like 20 Netflix videos, and thanks to Netflix engineering blog, Medium, Geeks for Geeks, different conferences. So in last 3 days, I watched almost like uh, I think 15 to 20 hours of videos and another 15 hours of reading technical papers um, to come up with this slide. This slide is a mix of all the many of other slides that you may find on internet. With that being said, I'm not expert in most of the technologies um, here, but I learned it along. And some of the areas, this topic will give you a 360-degree view, and I might not go into detail into some of the views. If you want any of the details, someone expertise here can talk about it, or we can or suggest that I can probably present that as a next meeting. We'll go deep dive into that. Okay, with that disclaimer done, let's start off with Netflix. I know most of you watch Netflix all over the world, but let's see what actually happened to Netflix, um, and what is the timeline for Netflix. So Netflix actually started in 1997, back in the day when you have Blockbuster and all other kinds of um, video CD place. You have to go to a shop and go get CDs, and every day you have to return it back. And slowly this mail model came, and then slowly subscriber model came, and then you have to put the queues. I remember putting Netflix to the queues, and then slowly in 2007 was a breaking point where Netflix started using video streaming. And then in 2011 they started with producing their own content, where they create, they pay for production, actors, everything in house, because buying media is expensive. When you any other media that you see, um, for every different country, it's actually expensive, copyrights, legal, and everything. So they thought, let's cut all that and get into production since we have the platform. And they expanded outside of US in 2016. Then they started, once they saw the scalability was pretty high, they actually introduced binge watching and encouraged people to watch more and more, because this is a time where they started working with ISPs for Open Connect CDNs. And then slowly they started um, expanding all over the world. Okay, so on a timeline by ways, like 1999, the DVD mail, and then slowly they started supporting device to view, and now they have over 1,000 devices that can view Netflix. And if and latest feature that they came up with was download and go. This is where one of the Netflix engineers' son wanted to make sure that um, how can I watch Netflix faster and when I'm on the road. So then they said, okay, we'll create a feature called download and go. So you don't need to use the network and your kids can actually watch. So they started doing that. And within like, I think 3 to 4 months, they came up with a feature that you can watch, download, and for everyone. That being said, that's one of the feature that they added in 2016. And then, okay, so how does Netflix work? It looks so easy, right? You see this kind of screenshots every time you log in, you have a login page, you have different icons, you have different rows. Okay, that looks simple. Okay, if someone asks me how Netflix works, well, I use my device and it connects to Netflix cloud service for anything that doesn't require data or content, and for data that is needed, it uses CDN. Okay, that answers if you want to tell to one level. But for us, we need more details. Okay, for technical people like us, we'll say, okay, the request comes to Zool and then the website, then you have edge gateways that goes to network services and it gets to Memcache and Cassandra. Okay, that explains, but I want more details. Okay, easy answer. Tell them this. This is how Netflix works. Easy. No one will ask you more questions. And if they ask, then say, okay, just zoom into this. You will see Netflix works by making sure that it's a connected system of asynchronous microservices and different uh, modern technologies, totally disconnected and functioning seamlessly with 99.9% accuracy.
So
Wow.
this is a it looks like a microservice mesh, right? Which you are not able to see because there are thousands or like hundreds of thousands of services, maybe.
Exactly. Yeah.
Mm.
There's thousands of services. But for us, right, when we watch um, Netflix, right, every time you see here, the each images is a Netflix. The login is a Netflix. The content suggestions is a Netflix. What image you are seeing is a different service. And when you see the search part, that's a different. So just in this one page, there are over 70 main services running, and in the backend there are around 700 microservices that suppose that 70 microservices, and each of them are actually uh, highly scalable. Okay, so in the let's look, I got this from um, one of the uh, presentations done by AWS Web Services by Netflix engineer, that there are hundreds of microservices and there's thousands of daily production changes. Netflix has mastered the art of dropping the code in production. Every week, they have approximately 4.5 deployments done, and there are hundreds of thousands of instances, customer interactions, metrics, thousands of hours of stream data, and lots of uh, engineering ops. All the engineers are DevOps, and they're working on it 24/7. Um, and Netflix has over 800 plus 800 million subscribers in 200 plus countries, and basically, let's come to the, okay, this sounds good, but as a engineer, right, I need to know more details. Okay, this all this doesn't work. I know it's easy to answer someone when you don't have much time. Okay, but when they have more time, you can show them this diagram. Okay, so I have a device, and from my device, I will call the ELB, Elastic Load Balancer, and that will call the Netty server, and Netty server will actually call the Zool, and Zool will connect to the Hystrix. Zool will do all the input filtering, security, and making sure all the transactions are sharded and routed, A/B tested, and then send it to Hystrix. Hystrix is an interesting one thing I should bring to this forum is Netflix is not only a streaming company, but it mastered and pioneered the art of creating. Whenever it sees a challenge, it actually comes up with an open source platform, um, or open source solution that can be scaled out and used by every other country, every other application. Sorry. So Hystrix is one of this that they faced an issue of how services interact with each other, and each service is meshed to other services, so they come up with Hystrix. And now if you use Java Spring Boot, you can just add a Hystrix annotation, and then you write a callback function, you can actually use that. So that solved their problem of when one service is calling another service and one service doesn't respond, and we'll go into that detail, like how that works. And then in the backend, they use some Cassandra and MySQL, and they use Chaos Monkey to test uh, different levels of the system to see which one, as the word says, it just says that um, what is my point of failure. So they add Chaos Monkey to everywhere, and they see which one will fail, so that they can do all the time. And then you had Chewbacca, that's a kind of like a logging platform and logging collections. And then you have Elasticsearch for all this metrics that comes into it. And you have Kafka. You have two levels of Kafka. One is just to get everything, and then you use Apache Samza to actually um, distribute the Kafka to different. Second Kafka is basically to Kafka topics, and then you put that to search. And then you have the some services which use for transcoding. Okay. They use for transcoding, they put it in the queue, and they work as part of AWS, and all the data is put that to Open Connect. And there's an interesting story about how Open Connect comes. I will come back to that. And I'll be bringing this image again and again. This is just to give you an overview of from this to this. Okay, let's give a 100K feet view of what actually happens. So Netflix is not Netflix unless it has a content. So you have content creators. Content creators is um, it's basically it may be Disney or it may be some other third party content, the movies that are created or Netflix in-house movies. It has to be uploaded into some place for someone to see. So you have to upload the data and you have to process the data so that it can be broken down into smaller chunks based on device latency and network, and then it has to render based on the client device and how it needs to render. And then you have content consumers, that is people like you and me sitting on a couch and watching from our network and from our devices. And then you have consumer analytics, which is key for most of the systems that they do, like what actually happens, uh, how the user is behaving, w- what movies he is watching, and if he is having any issues, he calls the customer care for troubleshooting and diagnostics. All those events are actually kept there. And also based on your past views, what if you watch season one, so you are interested in season two, so that will be on top, or preemptively um, getting the content to the CDN so that you will have a better experience. Or if more people are using watching a series than in one particular zone, then have that available. So Netflix has lots of in-house creations, and they also use the distribute they distribute also for external films and TV shows. So how does that happen? So that happens by they upload the content to AWS, and AWS actually takes a worker threads and formats that in parallel, break that big. Imagine the content as a big train. So they break that down into smaller compartments, and each compartment is formatted into different components. So if you have 50 GB of data, um, then it will break that down into smaller chunks, and then each smaller chunk is then again separated out into different formats and different resolution. So if you see one movie, they have 7,000 um, files of the same movie in different permutations and combinations of format, resolution, and based on your network speed and your device, the format and the uh, resolution will be used. And one thing is Netflix optimizes for different network speeds. So if you're in your house, the bandwidth is low, suddenly it will go from 4K to 1080p and 1080p to even lower, so that you'll see picture granulated, and the data is again when your network is back up, it will again bring the data back to 4K. So they automatically do this real time streaming. So when you watch, sometimes you see grainy, sometimes you see. So in the back end, what happens is, even though you have the packet which was 1080p, but the service, which is a streaming service, will actually see that, hey, I have a better network. Let me go preemptively get 4K file for the next second or next minute that this person is going to watch. So if I'm at 1 second mark or 5 second mark, so by 7 or 8 second, you'll get the 4K packets so that you can watch that. And then you have lots of processing that you have to do to the file, like subtitles, then you have to do disclaimers, then you have to do language, um, uh,
I
coding,
think
and
it,
yeah.
just a reminder, I think you're discussing the content here, but like you're going back to streaming. Do you have that in upcoming slides?
Yes, yes.
So if so, I don't want to confuse the people. So
Okay, so media validator is they use the Archer style to actually detect dead cells, machine learning to tag audios, and QC for subtitles, quality control for subtitles to make sure for different languages the subtitles are good. And once the data is validated, they upload the data to the content delivery network across the world, so that files are closer to the user, and there's a less expensive, better quality, and more scalable. So in terms of transcoding, the from camera to trans to the customer, you take the camera input and then you transcode or encode that, and you transcode to different formats based on your devices. So they do lots of different processing and they test everything, um, as you can see in the screen. Okay, so content consumers sit back. So here's so that is like pre-processing that's done by Netflix. So now you come in, and at the comfort of your home, log in. So the login page and everything, it uses React Node.js because it's fast and uh, pretty lightweight. And then as you log in, you'll see all the other services that are called are actually goes to the uh, edge service. Edge service will have connect to the network cloud, and it will say, okay, I want House of Cards. So House of Cards will go to the edge service, and it will say it will get the play data, and from play data it will say, okay, this person is going to cloud to get this data from, and then based on your network speed, your device, and your customer type, if you subscribe to 4K or 1080p, the CDN will deliver the data. And then originally back in the days, network was taking so much bandwidth. Then it asked Netflix, internet service providers, like, how can we help you? You know, we are taking 40% of your network bandwidth. Everyone is sitting at home and watching. So so Netflix came up with a good idea, like we will create our own OCA, Open Connect application, where each of the ISPs will actually store the movies across the world, so that the ISPs don't have to spend uh, thousands of petabytes of data across the network, when only thing you have to do is a URL, and the geolocation will actually find out what's the best movie and send it to you. Okay, so from a consumer flow, right? You have a client Xbox or something which actually logs in. You have a landing page, you have billing selection, and you click on a movie. So when you click on the movie, it sends the network speed, format, location, device, and it finds the best Open Connect for that file. And there's a ping to the Open Connect to make sure that, okay, you have the Open Connect is available, and get to the lowest, fastest one, and it also stores what's the default setting, and it will use that, and it preventively get the data so that it will be faster for you next time. And Open Connect CDNs are basically nothing but having data in different continents. So whenever people need to do something, and if one goes down, it will get from other one, or if and so the network is pretty. Uh, n- uh, what EC2 will do is, Amazon will just point to the nearest location based on your device, and the CDN will just get the data from that ISP. So Netflix is tied up with all the ISPs across the world to say that if you want your network to be less jammed, just take this device that they created and use it, so that it will help. So it's a win-win for both Netflix and also for the ISPs across the world. Okay, now coming to, okay, how this works. When I click on the play button, originally, right? I will go some slides fast, some slides slow, but you can watch this later. And you can pause it. So originally, this was the original design that Netflix came up with. Is I have a from device, I have a proxy. When I click on a play service, what actually happens? Or when I logged in, there's a sign up service, there's a discovery service, and there's a API play service, and everything was bundled as one monolithic application. Everything was synchronous, and then in the back end you had a domain specific content. So in the new one, what they did was they broke down all the services, one services to based on the function they broke down to sign up, discovery, and API. And then Netflix, even even earlier on, they thought that okay, I use REST services as RPCs, but what is my actual need? My need REST was simple, right? To communicate between services, right? It's pretty standard, but most of the use cases what Netflix was using, it's neither REST or RPC. Um, it's pretty unique for Netflix because it it wanted something more from these services, and even if you don't use REST or RPC, it would meet their requirements. So what they came up with is they started using gRPC, which is actually protocol buffers, which actually clients automatically generate code for different components for bidirectional flow of the data. If you want, we can go into that little bit details later, but that's the key of HTTP1 to playback to gRPC and HTTP2. Um, so in the original implementation, you had originally coupled clients and high binary couple, only Java and unidirectional communication. Once you started gRPC, it became beyond Java. You're beyond request and response, and limited coupling and minimal operational coupling. So they kind of use this, and gRPC is you can generate snippets, and you can actually download code, generate code for different languages. So you are not limited to Java shop, which
Could
primarily Netflix was a Spring Boot Java shop, and now they want to try out other things and still be compatible with old legacy applications without breaking them down. So gRPC is the way. And then, okay, I click on play data. What actually happens?
we don't see the slide changes. We are still seeing the REST versus RPC. So,
Oh, you know,
Praveen,
now you see.
no,
Okay, let me new screen share. Let me share again. Can you see now?
no. How about others?
Okay, let me stop and start screen
Yeah,
share.
yeah. Okay,
No, even I wasn't able to see the changes.
okay.
It happens. Once you're back, let me know. Can you see now?
It's loading, I guess.
Can you see?
Not
No,
yet.
no,
No.
It's still loading.
It says you're screen sharing. Is it still like that?
yeah,
Yes.
Okay. Should what should I do? Should I log out and log back in?
Um,
I don't know if it's maybe.
okay, we can see now, Praveen. So can we go back to that RPC slide, the gRPC, the other one? Okay. So I hope everyone knows like about HTTP2. I think recently, like if you want, like if you read about HTTP2, it allows all the bidirectional streaming. So that means like once you open the connection, you can continue to send the data without closing the connection. But like whereas in HTTP1, um, you are limited on like how long you can I mean, like how long you can do this bidirectional communication. So yeah, there are a lot of other improvements in HTTP2 that I'm aware of. So gRPC leverages all of that, as far as I know. Mm, yeah, feel free to read offline, and like that'll be useful as well. Praveen, please continue. You're on mute.
Oh, I was talking on mute. Sorry.
Yeah.
If anyone has wants to know any topics in detail, we can park it off and then we can actually go into detail session. Or if it takes more time, then we can
Mhm,
have another session. Um,
mhm,
okay, so they made improvements with gRPC and HTTP that significantly improved their performance. Now coming back, what would happen? What's happening when I click on the play button, right? That's what, from a client perspective, right? Once you hit the play button, this is the API. Basically, you get send the customer ID, you send the customer ID, you send the title, I need this title, house of cards, and this is my device ID. So internally, this is a Epic microservice or something, and then inside that you have three different microservices, which actually calls customer info and then device info, and then it gets data from customer and device and call decide play data, which will actually go in turn play the data from the CDN. Okay, but this is like if one fails, right, you are stuck with other services, so we have to do something different. So this is the existing traditional flow that they came up with. Like when you initially start, this is the original flow. So you have a get play data that used to call, in that service used to call three different services, and first two services used to get data and send it to the third service decide play, and then get that from three different customer service, backend device service, and play service, and then send that back to the thread pool. Um, Going beyond a little bit into what actually happens is when one request comes, you have response for the title, and then one request, you have stream of responses. So you're planning to do multiple titles at the same time, or you're downloading some data. So then you have to stream at one point. I want to download season one, season two, season three, and you get all the XYZ here, or you have multiple requests, multiple. So they have this beyond request and response, right? This is the concept of beyond request and response, which um, they want to accomplish.
yeah, and that won't be possible in HTTP one. I think even I think
Exactly.
exactly not all use cases can fit there. Yeah, I think that's
Exactly. So this is something that I had to go through some other slides by uh, in one of the Open Connect forum. And then this is how the asynchronous workers work. So what they did was, instead of having one service takes the thread pool, takes all the service, they actually changed that into request response loop, and they have worker threads and they have request response loop. So they made everything asynchronous, and as things work, um, things used to work seamlessly. So how did they did it? So what they did was they took the service of play data, and then they take the get customer info and device info, and after this is passed, you send that to customer info data. So this is one event, this is one event asynchronous, and then once these two events are done, the event then return this. So that way, you can get these two done in parallel, and then you can actually send that here. So if you see, this is synchronous execution plus asynchronous input IO. So they did something like this, so which helped in blocking request add-in and non-blocking IO. So this is some change that they did. And then in the backend, once you click the play, what they did was they found out that they do, Netflix does almost like uh, 5 deployments or 4.5 deployments average per week, and they make lots of changes to the backend data, and they have legacy applications which which actually uses the older format. So they what they did was, the backend data, when they're changing the titles or column names or anything, they actually created a data service, so which creates an abstraction between whatever happens, um, and then they created a materialized view to get all the data cached, so that anything mainline flow of data that you get will not be impacted by your deployments. And they test everything, So what user wants, the main flow, uh, I need to get the data, I need to get customer info. It's always cached, anything predictable operations and everything. So they reduce the dependency of once it's materialized, right? It caches everything and reduce the dependency of what would happen if the system fails. So if something fails in the materialized view, that's a big failure. But other than that, you can easily add data sources and everything, and it works seamlessly for a customer from API Play service. Now, in terms of load balancers, right? So Netflix is responsible. They use Amazon's Elastic load balancers to get the traffic into their system. And what they do is they have two tiers of load balancers. First is just to do a round robin, DNS based round robin. So when the request lands at the first load balancers, it just goes to one of these. And then the second tier of load balancers, which performs round robin based on the distribution of request across the distance, or whether it's the same zone or a different zone. So this way they're dividing the request and conquering it. So if and they so even if one zone or one load balancer fails, they always have a way to uh, work. So how does the interface, right? So you have the services and you have user service, you have microservices that work. They're all interconnected, right? So this is where you have one service, customer service, which actually calls other service, and then you have playback service. So they're all interconnected. So they created, like, if one of the services is slow in delaying, and then they will call that uh, a default response, and they will send back to the interface, so that mainline flows will always function with seamlessly. So they have they separated the services based on critical services, and 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 they treat servers as stateless. And in terms of caching, what um, EV caching, what um, Netflix did was memcache was actually using memory caching, right? Um, Netflix is pretty technology savvy company, and they care for um, how much money they save. So memcache, as the name says, is memory cached service. So it is pretty expensive, and so what they did was they actually um, found out that at the cost of getting high expensive memcache, um, they used SSDs, solid state devices, for technologies which sits on top, which is not as fast as a, a memory, but it's still pretty fast. And the cost of 1 terabyte of data on SSD is much lower than the same amount of RAM. So they created the EV cache, customized the machine mem cache, and whenever any write operation happens, they made sure that the write actually goes to both the systems, and only after the write is written to both the systems, cluster A and cluster B, they will acknowledge that write is done, so that even if one system is down, the other system has 100% of the data. And read, you can do it from both the systems. Okay, now coming back to this diagram.
So I'm
Yes,
sorry, Praveen, you are saying like for doing a caching solution, they used SSDs?
yes, EV cache.
Yeah, just I think there is some correction here. Like I think they still use the memcached, which they customized and call it EV cache, and they customized for the reason of I think they build their own clients and efficient way to manage memcache. But I think the SSDs they use for cold storage, not like replacing the memcache.
Yeah, so they customized. What they did was, since most of the applications, right, use or frequently use data which needs faster responses, they actually cache that in instead of original servers. So Netflix has deployed a lots of clusters in the AWS EC2 instances, and these clusters have so many nodes of memcache, and they also cache the clients. So at the client levels, they are actually using SSDs, and also some of the
Uh, okay, I think that is somewhat. Maybe we can park this towards end
yeah.
and come back to it later. But like how they have used SSDs, whether is it to complement cache or like replace, like that is something we can discuss towards the end.
Yeah, from
Even I
what I
have
read is,
questions.
yeah, what I read is that when nodes go down, right, all the caches go down, right? So it is,
Yeah, that's the reason they're using as a cold storage to bring it, but not like as by replacing the cache itself.
yeah, they're not
So
100%
that's what like.
replacing. Yeah, they're not
Mhm,
100%
mhm.
replacing, but they want to reduce the cost, right? Because they have so much data and they,
Yeah, that is another thing, and
yeah,
the reason why they didn't find like memcache, like which is limiting their needs. So why they had to build EV cache on top of memcache? So that is another question I have.
yeah.
But like we can
Basically, the
talk.
EV cache is a wrapper around the mem cache,
Mm.
so that the data is sharded across multiple copies of in this shared nodes. So every time the writes happen, all the shards are updated too. So it's a customized. They're not 100% replaced memcache, but it's a wrapper over it. So they use the it's a hybrid version to reduce the cost.
Yes. Yeah, and it's again they made it open source, I think EV
Yeah, they
cache.
made it. So that's one thing. Whatever Netflix does, like Histrix or any other platform, they actually made it open source for everyone to contribute and make it better. And the lucky people here is Amazon, which all these devices are on, and they leveraged all the expertise from Netflix and using that for Amazon Videos service, and also other technology companies. Okay, I think okay. Now coming back to this diagram, we'll come back to this diagram multiple times of what is actually happening to again bring us back to picture, right? So we have a device, we have a elastic load balancer, we have netty servers which will actually go, and then we have Zulu. Zulu is nothing but
We don't see that diagram that you're talking. The first architecture diagram you showed, right? We are
oh,
seeing the load balancer one.
all right. I did it stop again. Looks like it stopped again. I don't see that.
We can see now. I think you are discussing the other diagram, right? Can you go back to that? So yeah, this one.
Please
Uh,
unmute yourself.
I'm again. Yeah.
Mhm.
So there different technologies. I will say what contribute what Netflix contributed to technology is Zulu, not Zulu, sorry, Histrix. Histrix, they created a customized version, right? EV Cache, Open Connect, um, some of the uh, different searches, they actually customized it and they made that open source. Now coming to the backend databases, right? So where is all the data stored? And we see the Cassandra and MySQL. So let's get into where's our data stored. So Cassandra in Netflix stores most of the billing, user info, relational, transactional kind of data in the MySQL, which is deployed on Amazon EC2 in InnoDB clusters. And if you don't know InnoDB, it is nothing but you have a MySQL, classic MySQL, which is open source, and InnoDB is basically how you have in Oracle a cluster. So you have a master, and then using the master, you have a master and slave or
It's a
active path.
storage engine, right? So
Yeah,
it's one of the storage engines
yeah,
supported.
it's a sum of the storage. So you always have three
Mm.
nodes underneath it minimum, and so you always have replications that going on between the three. And from a client perspective, those are all transparent. Um, so you can easily switch, do deployments, and bring it up, and so it's pretty scalable. And in my work, we are actually doing this migration right now, so I can talk about it for a little bit more. And it's pretty good. It's pretty scalable. Lots, many companies are using InnoDB if they want to scale and do a resiliency. And they use Cassandra for lots of viewing history, where NoSQL and viewing history, and for lots of metrics on all this data that they get. They actually use that for NoSQL. And what they did was, here also Netflix, initially they used Cassandra, and then they quickly found out that they were getting over uh, petabytes of data a day, and so now they have over 50 Cassandra clusters and 500 nodes and 30 terabytes of daily backups, and biggest cluster of 72 nodes, and each cluster writes around 250 writes per second. And they were running out of space. So what Netflix engineer did was they created a compressed viewing history, and they reduced that using kind of like map reduce kind of thing. Whatever information you need, you actually separated that into different nodes, and that which can be easily consumed. So there have, and then they archive the live viewing history based on certain parameters like last 30 days or 60 days, and then compressed view for most requirements. And then they use Apache Chihuahua. This is basically a collection of logs and monitoring analysis and dashboards. So which actually uses the data to in the form of Parquet, and they write the data to Hadoop file, and then they take the big data and put it in. They actually use Parquet and they upload it to Kafka. And what Kafka does is it actually is responsible for moving on Kafka to S3, Elasticsearch, and secondary Kafka topics based on. So they break down the data into multiple topics, and then they use the routing traffic using Apache Samja framework for live history and compressed view. So today, right, Netflix uses Kafka and Apache Chihuahua to inject data that is produced in different parts of the system. And Netflix provides almost 50 bits of data, that 50 petabyte 1.3 petabytes of data per day, and 8 million events that consume 24 gigabits per second during peak time. And this includes error logs, UI activities, perform events, video viewing activities, and also troubleshooting and diagnostics. So when you call the care or support, like I'm having a problem, before even you say your problem, they use the Elasticsearch, which has all the metrics of what you are doing, when you are doing. They will actually suggest you, maybe your network was bad, or the content you are watching, we had some privacy issues, or you're in a different VPN and that country forbids that movie. So they can have all that information real time using this framework. And Elasticsearch, this is in beautiful thing that lots of companies are using. This is pretty lightweight, scalable, and product for data visualization, customer support, error detection in system, resources, sign up or login problems. Um, and approximately Netflix uses around 150 clusters of Elasticsearch, and 3,500 hosts, and it uses around 1.2 petabytes of data at any point you can search in Netflix. And then you have Apache Spark. This is one of the third key metrics of what bread and butter for Netflix is machine learning. This is a topic of its own, where uh, Netflix uses lots of machine learning based on the data that it's collected from you. And it uses that for movie recommendations and other suggestions, so that you can stay on their platform for longer and you get more customized view of what you want. So based on, to give you an example, right? when your page first loads, you see multiple tiles, right? So each tile, the personalization based on your likes, based on your past viewing, you will get a custom images of the movies too, even the cartoons that you watch. So each movie has around 30 different um, pages, and based on your preferences and your collaborative filtering or content based filtering, they will find out like if two users are having same kind of interest, um, then you may actually watch this movie if I keep this image. And content based filtering, what they will do is based on your information that you have, based on your past users like, and the content that you like, you may actually watch this. Or if I put a, action kind of, you watch lots of action movies, if I put action kind of image, you will watch this video. So they customized everything. So whatever you see, no two persons, even in the same profiles that you have, no two persons will see the same um, tiles page at any point. So that's all that is done via machine learning, and for devices for longer use. And then we have Titus. Titus is nothing but an application container platform that's used for making it scalable, right? It is a platform which you can, if you know Kubernetes, right? So you can scale up, scale down. So Titus was built internally at Netflix and is used in production to power Netflix streaming and recommendation and contents. And it also has scheduling support for applications mainly used for Docker images, and it talks to AWS auto scale services and using AWS gateway to scale Docker on AWS. So supposing you have watching the new House of Cards or new kind of movies, or in based on, so they actually scale up the images, or uh, preemptively, if they're doing some new um, concept, they will actually scale up, scale down using Titus application. What it that way, it helps in dynamic scaling and enable cloud resources that are not needed to be used, and use only for um, things that you want. Also during the encoding and decoding of the content, they actually use Titus. um, and then coming to appendix, where I use some of the Slacks, Medium and Netflix blogs, and different kinds of Azul versus HA proxies content. Now coming back, if anyone has any questions, we can discuss that now. And thank you. I learned a lot, Naga and others, for giving me opportunity. This was a nice
Yeah,
learning experience.
yeah,
Even though I've not worked on most of the topics, it's was it. I had a great uh, appreciation for these topics, because I can compare each of these topics to what I use in my uh, uh, at company like ELB, like elastic load balancers. We use A10, and with instead of Netty server, we use HA proxy, and we instead of Zulu, we use A10 and HA proxies when on a Kubernetes clusters. In Hystrix, yes, we use instead of Cassandra, we use something else. So everything that we see here, um, I have a parallel technology or APG technology that we use to
correlator.
satisfy this one.
Mhm.
Thanks. And if you have anyone has any questions, or if anyone needs to correct me, I'm willing to listen, because I'm not master in most of this. I just have the breadth of it.
Okay, thanks, Praveen, for putting the slides together and going through all those references. And yeah, audience, like if you have questions sparked, please feel free to open up. And Drupad, you want to go ahead?
Yeah, I have a question about REST versus RPC slide that you had shown us. Can you please little bit elaborate on the second point? I couldn't understand because I never worked on it, so that would be helpful. And also, I would like to, if you have some little bit time, can we also talk a little bit about that HTTP2 thing that Naga mentioned?
For the gRPC. Yeah,
Mm.
this is for the gRPC, but I'm not specialist. I haven't used gRPC or HTTP2. I just learned it. But if anyone here knows more about it, can speak up. And
I think his first question was on the RPC. If you want to clarify the second point he was stressing on,
most services
or not.
yeah. So that being said, right, so bidirectional and streaming kind of, so the use case that Netflix has is, once you request a play button, right, you need to get a stream of data. So it's not like a standard request response, correct? You need to once, and then once the connection is open, it continuously checks to see your network, and if your network is bad or good, it has to adjust the next packets. So it is originally, when they started with HTTP and RESTful, you had more buffering, though it used to use the same functionality of when your network goes bad. It didn't actually uh, solve your problem of effectively streaming, seamlessly streaming. So that's what it didn't follow all the RESTful principles, and URL didn't represent a unique resource, because the resources were, even though the HTTP, the resource was same, the parameters passed in the call was made um, them at a RPC call, effectively made them an remote procedure call. So when I say that, it they were not, they were using an axe instead of using a screwdriver. So it was, though it worked some places, you can use it, MacGyver it, but it was not the right scenario for them. um, and since the services of what you are kind of using is agnostic to whether it's a REST or RPC, their main requirement was to get data in a streaming response, whether it's a one stream, request stream, multiple request stream and one response, or stream request and stream response, or one request and multiple stream response. So this is their requirement. So if you see this one, right, if you have written a HTTP, it doesn't follow this. If you want to do this in HTTP, then the calls will be a lot more, or you'll get lots of timeouts, or you have to customize and reduce the timeouts, or you have to put that in queues and send that out. That was not the format. And in terms of gRPC and HTTP2, this, using this protocol, it achieved the need of what playback authorized, and the buttons authorization that they needed, like when what decisions to play and streaming and everything. And in terms of authorization, I read it in um, one white paper, is how Netflix authorizes the keys, right? If you see, if you any, you have OAuth, you have JWT token and everything, right? Um, when you try to connect to a system, originally, every time you send a request call, you have to send a JWT or OAuth, and then that used to be validated across the network. Um, in Hopefully I can find that main slide. Um, yeah, that out here, right? HTTP request the authentication. So every time the request comes from client, it used to go here, check the authentication and everything. So what Netflix did was they created a session, and I think this there is just one session for authorization video in Netflix engineering blog where they talk about how they used authorization. They tried different things. So today, how it happens is I'm diverting a little bit, but I just want to mention that they actually cached if your device is logged in, it would not ask for the sign up um, till something else, some event happened. So whatever ID that you have, it will recache that ID and authorization at internal filter bound. And from here on, it's all back to basics. They're not using any checking.
So
So
the
that, mhm.
Yeah, so the you said like gRPC optimization was done for streaming. So is this like just for a streaming the actual video content to the consumer, or is that for all other things like doing authentication, authorization? I mean, all other things. Like what was
Um,
that for?
I think the authorization stuff was not like the one which gRPC was meant to do.
Authorization for gRPC.
So yeah, so I think it's just a general one of the other practices that companies follow. So on the, I think gRPC leverages HTTP2. So it's gRPC is kind of uses internally protocol buffers to
Proto
mm,
buffers.
yeah. So the actual concept of HTTP2 is actually that, like, I think you don't have slides for HTTP2, but
No,
like yeah, but I can quickly share my screen so that I just googled and
yeah,
just to
sure.
give people, and I'll let you share yours in a minute. The HTTP2 main proposal was like a lot of companies, they were wanting to reduce the network overhead and they want to reduce the latency timings. That was the main goal. Initially, like HTTP 1.0 was all like request response model. Like every time you have a request, you need to get the response and you start another one. But HTTP 1 introduced like multiplexing request. That means that one client will be able to send multiple requests, but you need to wait from server to fulfill all the requests in the same order it was received. So HTTP2 made like multiple improvements. One, I think even if you see the headers, there are a lot of headers like this in HTTP 1.1, which was all text based. So the moment you say text, it's going to take space like when sending the request over the network. So in HTTP2, it's all again like even the headers go as binary frames. So which means that it's going to compact your headers also a lot. And you have this general pattern like headers and data frame in the HTTP2, and the official concept of like the streaming came in HTTP2. So which means that in the request you send both. You can just send the headers frame, or even like with a request if it's a post. And similarly, there is a response streams and request streams. They can continue to go. There is no restriction. Like you can send as many as request, and the server can respond at its own pace. So nobody is blocking. Like client is not blocking the server, and as soon as he wants something, he keeps sending over this by sending another stream request. The server also in a similar way, in its own pace, as long whenever it processes a packet or stream one, it sends a response for that, and it picks the other one. So yeah, I think this is an ideal one. So how the connection works. So by using this, like I think their Play API in particular was able to leverage this because they just keep putting the request for the next frame. I mean, like as they continue to as the user continues to view, they can continue to put the request for next chunks, and the server can continue to send the content i- at its own pace. So they're using the same connection as long as feasible, and mainly it's non-blocking. So that's a key. I hope this clarifies something, but like feel free to read up on your own to get more understanding of HTTP2, and the gRPC is a framework I think which leverages this HTTP2, and they use protocol buffers for compaction and binary communication.
Yeah.
So
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 basically, what
in
it
terms,
does is the data is at binary level. Um, so once the data is at binary level in using proto buffers, the the in the it takes the network it takes less network bandwidth to transfer more data because it's at the binary level.
yeah, but if you take a like your slides, we were saying, right, we are already compressed the videos, like it's already in those different formats like 3GP or whatever, that MPEG and all. That's already a compressed video format. Like, why do we need one more compression over it?
So even though it's compressed, right? Every time you watch a video, um, you are
Praveen, feel free to share your screen. So I just stopped. Yeah.
okay. Let me know when you see it. So
Yes,
even
we
though,
can. Mhm.
yeah, even though
Good.
it's actually compressed, right? You're not actually using the full file at the same time. It comes in small chunks, right? So what gRPC does is it actually makes sure the data is coming in smaller chunks, and it's just like how the code is. If you have a code, right? Whether the code is written in .NET versus C versus how it's how closer it is to the byte level, that much faster it will be. So in the internet world, right, everything is zeros and ones. So protobuffer will actually make sure that it is as closer to the binary code, and so that you can use the same format, and then it will be regrouped together at the client end and assembled it. So protobuffer has that, it says right in the header what is the device, whether it's a Chrome browser or it's a different. So based on that, it will actually stream it. At least that's what I heard and I read. If anyone wants to add anything more to that, then feel free.
Mhm. Okay. Please do more reading on HTTP2 and gRPC. I think it's good to learn. And in other questions from anyone?
This is the answer for all your other questions. No, I didn't see the comments chart. If anyone has any questions there, we can actually discuss all
Alex,
your.
do you have anything? Like I'm just trying to pick some names. If not, like
Or if you have, if out of this presentation, is there any topics that as a group you feel interested, then
yeah,
talk.
let's be on this slide. So I mean like the keywords or like the technologies that I'm aware, at least I can talk like so if anybody like looking to is interested in one of this, we can do a deep dive session. So example like load balancers itself, how they work. There are like different types of load balancers. You have mm, type 4, I think type 7, which works on the TCP, some of them, and some work on application level load balancing. So, and I think Netty server, many people use it for network improvements. Um, I think it's one of the famous library for that.
Yeah, client server framework, right?
Mm-hmm. Historics we all know. EV cache, I think like a session on like memcache and other EV cache. There are like many other companies also who have extended memcache to their own. I think Facebook is uses memcache heavily also. Um, if somebody is willing to do a deep dive on like how this caching is leveraged, that's also good.
Yeah,
And the
yeah.
Kafka deserves its own session, like how it's architected and what are the advantages for this.
Kafka and
So,
Kafka, yeah, topics. Each box can be. We can have a detailed deep dive session. Chaos Monkey is interesting thing. It's as the name suggests. It will create confusion in the networks, and it's an open source. You can actually install it in your network and test it out. Chavaka is also interesting.
yeah, I think I mean like every, I don't know, this all tech companies, they create their own
Mm,
logging mechanism or their own queuing, and like this appears to be a log or like events, right, which sends to Kafka.
yes.
So, LinkedIn has its own, and I don't know what's the name, and Facebook has its own. They call it Stripe, I think.
Probably
Um,
what if someone can present it is, comparative study of different technology, different companies, right? So Netflix, what it uses for ELB, what it uses for load balancing, like what it uses for backend database majorly. I know everyone uses lots of things. Like some uses Zulu, some uses HA proxy, some uses
yeah,
and
and I think somebody corrected. Yeah, even I forgot to mention on the filter, like Zulu is another video streaming service. I think, or I don't know if that's on. So I think it's Hulu. Sorry. So ZUUL.
yeah,
Uh,
yeah,
that's the
Zulu,
correct word. Yeah.
yeah. Yeah, that spelling is wrong. I think it's I got that from the internet. It's Zul, ZUL, is basically a gateway service that is used for dynamic routing, monitoring, resiliency, security, and it provides easy routing based on parameters, URL, and it also helps people who wants to do A/B testing, sharding the traffic, load testing, filter bad request, A/B testing. So if you're creating some new services, you can do A/B testing or canary deployment and uh, test the new service to make sure that it's actually you can partition the traffic, like use 10% to the new service and see how it's performing and if it's good. So all those kind of things you can do with Zool, and I need to correct that. It's Zool, and I can't correct that because it's not my slide. I got it from the Netflix slide.
Okay, Alex,
Oh,
you want to mention something?
yeah, would like to ask a question. Praveen, do you have any detail about how Netflix is storing the videos? I mean, are they using solid state drives or mechanical disks? And also how they handle, disk triple, disk IOPS or things like that. Do you have any details about this?
This is in terms of Open Connect, or this is in terms of AWS.
No, no. I think it's how the videos are stored, at the end. So I think, yeah.
Yeah, that is at the
Mm.
Open Connect level. So what they do is actually, can you still see my screen?
Yes.
Okay, somehow it doesn't show that green line. Okay, so basically what they did was they it's a physical box. It's a red box that they stored in all the data centers, and it is a SSD on that box, and they have, so for one movie, right? So they make sure they have 7,000 copies of the same movie in all the permutations and combinations, like whether it's a movie format and resolution, and device type, if it's an Xbox versus PlayStation versus something. So that's for one movie, and they have over thousands of movies, and they optimized it and they cached it at different ISPs. Um, and since they are on SSDs, they are actually at the ISPs. They are almost like, and they, on top of that, they created a layer of kind of like a memcache, or Elasticsearch, which will actually make sure that when a request comes in, it will it will speed up and go to the URL or actual physical location in that open connect to get to the file. So they even added that level of optimization so that uh, you will have seamless streaming experience. But internally, how they do it is, what is the latency? I don't know the details yet. We can find out. There's openconnect.netflix.com. There are some blogs in there. I was trying to read that last night, but it was already morning 3 o'clock, so I I didn't go into details.
Thanks.
But if someone is
Yeah.
interested, there's an openconnect.netflix blog.
Yeah, I think open, I don't know if they use fully for storing. I don't think so, but like they may use it for like efficiency perspective to minimize network. But like ultimately, I think all the data should be there again somewhere. But like, yeah, it's people can do their own
Yeah.
search.
So do you see the red box, right?
Yes.
So this is where all our movies are stored, and this is general ISP data center, or or wherever your junction is there. So if you are in Seattle, right? So if you are with Comcast, so Comcast location has this, or if you are in India, Tata Geo or something, then they have their own boxes like this set up in their
But
for each city.
I think this is something that Netflix should control, right? Otherwise, even though it's within ISP
Yeah,
um, uh, region, like all the power and other stuff,
yeah, they
which
pay
could
for it.
limit it. Yeah.
Yeah. So originally, right, if you see my slide, what happened was, Netflix was actually taking up all that network space, and all the ISPs were getting mad that, and you are actually taking all our space. So this one, right? So it was coming all the way from US or wherever it is, and then it was coming. If you're watching, it's Netflix is in California or someplace, and then data come from CDN or some of the data centers to, if you're in New York or Florida or something. So that was to take lots of, and then they had lots of legal issues of, why is a network.
Yeah, so I think just to for audience perspective, instead of saying Open Connect is like a custom CDN that Netflix built. So
Exactly. Yeah.
yeah, CDN serve the data in general world, right? Like Netflix CDN is like the Open Connect, which is
So,
customized by
so this is
leveraging this.
to discuss more about CDN, right? So there are different kinds of CDNs in the market. So before um, Netflix started with Open Connect, they actually use Akamai or Limelight or LimeWire, and their CDN gateway, CDN. There multiple big players are there, and then they said whenever Netflix sees anywhere they can optimize, they either optimize it or they create their own technology. So this is how they migrated from using a third party to host their CDNs still actually creating their own CDN hardware and embedding that into the ISP. And I think the same thing is also done by Amazon and other platforms, Disney and everyone. So they are kind of like the pioneers who did it. And I don't know how YouTube streaming works. Is anyone aware of that? I'm kind of curious now. What does YouTube use for CDN?
I
I think
think
YouTube.
they should be using Google now because they have Google Cloud, and Google already had a lot of data centers and like in their own CDNs, I guess.
So
And
do they?
they
I
have
think
their own network too, right?
yes, yeah. I
So
think
they
all
use
top
the fire.
companies they don't rely on public anyway,
But
so they have their own dedicated. Uh,
does Google also use ISPs rack space for faster delivery, or they use a different
I
method?
think I think the use cases of YouTube are little different. I think they may have little different architectures.
Yeah.
So I think it deserves. Let's see if someone can step
Mhm.
in to present YouTube. But like I'm sure there are articles for
Yeah, I'm just
about YouTube also.
search for that.
Any
Yeah,
other
the problem I think
questions?
with YouTube is the what they call long tail. All these videos they are not hugely popular, but are being accessed at any moment. I heard that popular videos they use CDNs, poppies, clouds, etc. But for long tail, every request goes to their data center, and so in this case, they don't rely on caching on the edge.
So I read that YouTube uses Google Cloud GCP Edge to run infrastructure which uses YouTube, and it uses an Google's global edge network to serve content closer to users.
Yeah.
Okay.
Well,
So,
Praveen, you mentioned before that one movie can produce 7,000 files in different formats, resolutions, etc. Right? Do you know if I mean, when this processing is happening, it is happening on a single data center, right? Some content creator
yes,
uploaded the original movie, then all the systems start working on creating the different formats, etc. Do you know what happens when this task is done? What they do to replicate this data to different data centers? Do they replicate all these 7,000 files, or do they run the same processing on every other data center they might have?
yeah, that's an awesome, excellent question. So what they do is, so if you have 50 GB of a file, right, and and they have this Amazon AWS worker thread which actually processes the, so all the hard work is done in AWS cluster. So of breaking down into different formats and everything, and then creating the multiple segments. So if your file is being needed in multiple continents, what they do is they actually, instead of creating 7,000 copies and transferring it to Australia, they actually send that 50 GB file there, and then they create like 5 petabytes of terabytes of data from that 50 GB by 7,000 formats by running AWS threads there in Australia, or Indonesia or someplace. So only based on, so they just transfer the data, the file, into that location, and they run it. Because if they do all the processing in one AWS and try to send it, broadcast it across the world, that defeats the purpose, right? They're again consuming, if a new movie comes, they again, instead of sending 50 GB one file at the best rate, they have to send almost 2 terabytes files to multiple countries, and then eats away everyone else's network. So from what I read is they send the file to different locations. Let me see if I have that image of the world. Where is that image of the world? I don't know. Okay, so they take that image and put that into different continents. Yeah, I think this one. So they take the image, right? If the image is generated and they put that into a continent, and then they do the AWS processing. um, because when you process it, right, if you are sending the same house of cards to China, right, or to Russia, then it needs Russian subtitles, Russian uh, kind of a uh, you know, contents and devices and usability, what is the main users use case. So they just create that content for that environment. If they use for Africa, then they have like almost like 40 or 50 different languages, so they have to encode that with different strings and different quality checks and also compliance, right? If you're like some house of cards is not legal in Saudi Arabia because it shows how the government is formed, and that defeats the Saudi thing. So they actually don't even show that some of the episodes or scenes. So they send one file and they reprocess it at different continents based on, if it's South America, like they use Portuguese or Spanish, based on the location, and they based on the device usage. And so they will only produce those ones which is actually needed.
Cool. Very thanks.
Yeah, I read that. I forgot to add that, but the processing itself, we can spend like a couple of days on that. That is such a magic. And then there is one thing. They're actually created a framework of how um, um, Netflix delivers the data right from the Netflix studios, and they're actually called Hawkins. I think it's based on a Stranger Things city. And if you search for that on the Netflix engineering blog, you will see a nice topic about how they uh, created a framework from right how to schedule different actors, how to get the legal fees, how to actually edit. So for one episode they need around 1,000 people, and which actors they want to get at which studios at what time. So they have created a framework for everything so that everything is optimized and the schedules are sent, and the data is produced and edited, and how they create different graphics and animations. Everything is part of the Hawkins project. Anybody, anything else you want to
Yeah.
add?
Any other questions from anyone? Yeah, again, like if you are interested in specific details, feel free to explore on your own and try to learn. Because I think once we know how things work, like if there are some similar use cases in your organization for some other work, mm, it'll get into your thoughts.
And the same concept, right? High level
Mm.
is applicable to Hulu, or like Netflix, or not that Hulu or Amazon videos. Some technology might be different, but most of the time they are the same. So this is the one that I was telling you, Hawkins, right? I was reading this also. Um, how they designed the Hawkins based on Stranger Things, how they designed that framework, right from first reel cut, and they created a framework to check and design system importance, then build versus buy, how they can leverage generating users getting buy-in, so how they're investing and adopting in more streamlined applications, how they're using this Hawkins bootstrap features, and so they're using this creative UI. They're also designing their own UI for editing and wrapping up using Hawkins design system. This is also interesting. If you want to read, this is just came like 1 day back. So your what I mentioned today is the latest one to 1 day ago. And
Okay.
okay,
Yeah, I think for folks interested in further reading, there are few people like who posted some links in the chat. Feel free to take them and read. I also posted like in the past. I went through the play architecture specifically. I think Praveen gave a teaser slide on one or two, but like it doesn't have full. I think so. To understand full play API architecture, there is a YouTube video which I posted, and you can take a look at that. And there are I see others also posted some links if you are interested in others chat. Yeah, I think the one Drupad posted and I posted, I think they talk about same thing, but like it's a video, the one which I posted.
yeah,
And obviously you can go to the company engineering blog, Netflix tech blog, so you to get updated on all the latest happenings
yeah.
on
Each one
Netflix.
you can actually do a like a topic to spend.
Mhm.
Pretty awesome. And they're not only supporting content decision making, machine learning, simple telemetry, reliability, sharding, GraphQL, content analytics, and batch, how the data is moved. So what I gave you, once you go into detail, right, it becomes like we just know the tip of the iceberg. The more you know, the more you know that you don't know anything. And that's what I can say. I don't know anything. I I just know a tip of the iceberg. But I'm
Okay.
curious to learn more.
Yeah. So any other last questions? If not, like we can end the session and get into informal chat. Okay. Thanks, Praveen, for putting this together, and thanks for volunteering to present. I'll stop the recording for